You were going to come by the house on Friday. Yeah.
Friday morning. Yeah.
Should we begin?
Yes.
Okay. Happy birthday, June, again.
Thank you, John.
That's a great beginning. So last month, I'm trying to keep some kind of coherence between these. We got up to the point where there were sophisticated, literate, record-keeping civilizations with full-time, more or less tenured astronomer, priests, magi, astrologers, whatever. But the point of the record keeping was to find pattern in what was going on in the heavens, and that information, the ability to predict, belonged to the pharaoh or the emperor, the king, whoever. It was for the head of state to make state decisions. And even though they were literate civilizations, the literacy was a very thin slice of the populace. And for that reason, it tended to be well-guarded information. In some cases, it was even secret. It was information that you had to be initiated into. That's not a very good basis for getting science going. The other important characteristic of what we talked about the last time in these very sophisticated cultures, the Chinese, the Egyptians, Mayans, Babylonians especially, the pattern they saw was the pattern in the data. There wasn't a physical interpretation. There wasn't a geometric, spatial aspect to the patterns they found. There wasn't a philosophy behind it. There wasn't talk of cosmology. All of this is going to change dramatically tonight, because we're going to start in with titled The Philosophers of Nature, that appeared in the 6th century BCE in ancient Greece. Somebody else has already noted, and if any of you have done a bit of reading world history and world religions of this time, this century is a remarkable time. There's something big going on all across the Eurasian landmass. In China, this is the time of Confucius and Lao Tzu, the beginning of Taoism. This is the time, the century of the Buddha. This is the century in which Zoroastrianism is coming together. This is also the time of the compilation of the Hebrew Bible. Monotheism is becoming an emergent basis for understanding the world. All these great changes are happening at the same time. The ancient Greeks are going to go off in a very different direction. They're going to start arguing about the physical world, trying to explain how it came to be, using reason, no particular reference to gods or mythology. Now, this is something that didn't pop up anywhere else. It has been called by an overstatement, but famously a historian about a century ago called it the only miracle in history. Too much, but still, it's very special what's going on. The people that we're going to be talking about are called physikoi, or at least that's what Aristotle called them. Physis is the Greek word for nature. So these are people who studied nature. They wanted to know. That's another phrase of Aristotle's. And most of what we're going to talk about at the beginning is going to happen over in this area of what is now Turkey, the west coast, by a group of Greeks, one of the dialects of the Greek language, Ionian, and especially at this place, and we'll get to this city of Miletus in a bit. Before I go too far beyond this, I want to point out that there's something, not only is the subject tonight in terms of world history pretty much unique, but so is the way that this nation, if you're going to call it a nation, is defined. It's unlike the other big cultures. It's not a place on the map you can draw a boundary around very well. Ancient Greece is a bunch of semi-independent, highly competitive, highly active city-states. There is no big empire, there's no bureaucracy, there's no sacred text, there's no priest class. This is a great environment for arguing. And if nothing else, science is at least a sustained argument about the nature of nature. So, oh, and I need this in here because a lot of times you read history books and they'll talk about the various people I'm going to talk about tonight, what they said, what they argued, as if we really know, as if they wrote a book and we can now look it up in a library. So just keep this in mind. But it's been pieced together well enough to tell, I think, an important story. The other thing that's importantly different about the Greeks is they're entering a time when literacy is going to be available to a much larger percentage of the population, only 10 or 20% maybe at best, but that's still a huge difference from what you'd find in other advanced cultures. It's a level of literacy that you won't see again in the history of the world until the 17th century in Europe, which is the time and place where we say modern science and modern astronomy began. And I don't think that's coincidence. I think there's an important tie-in between those. So as a result of this literacy, we know what these ancient Greek philosophers, nature philosophers, thought. Unlike other cultures where we know what battles the king won, what spoils he was able to take, how much grain is stored in the silos. Here we know what people were thinking and how they were arguing. And the arguments could be evaluated on the basis of truth that was put to a test, very much interested in proving things. The truth, such as it wasn't just a catechism to be learned or a secret that you're initiated into. It was something you could probe coming from the same word root as prove. So my idea on why the Greeks is that they had the conditions better than other places for sustaining arguments. And I think it's mostly geographical. I don't think it has anything to do with genetics or an intellectual capability. The geographical situation of having these semi-independent city-states, sometimes forming alliances, other times going to war, highly active in trading and commerce, backed up against other great civilizations, trading with them, but always able to run to their home city and never concerned about an overarching orthodoxy that was imposed by a centralized government. And I want to give a couple examples just to get this going, to see if you'll buy into this the way I feel about it, at least. Here are some examples, I think, that are related to the ability to sustain an argument. What happens if you can sustain an argument? Most arguments fall off. They don't last very long because they fall off on one side or the other. You end up with a fist fight or a riot or warfare on a larger scale, or the other side of that is a police state, martial law. Eventually it can settle down into something more comfortable, like a stable bureaucracy where if you want to know the truth, you ask a priest or a policeman for the orthodoxy. But in between those two states, where it's possible to keep arguing, there's at least the possibility of new ideas arising. Here's some examples of things that happened in that ancient Greek world that are pretty much special in the history of cultures. Let's suppose you go into the marketplace, the agora, or agora if you prefer, and you start arguing about the price of olive oil. Now these are port cities, and you can have your choice of olive oil from a lot of different places, and when is it coming in, and how much is it compared to wine or something else. What if you want to buy it now, pay later, or do some trading? If you start getting highly argumentative about the value of things and how to account for it, bartering isn't as good as what emerges here. A rational, transportable wealth, coinage, appears in this part of the world at this time. Suppose that a common argument, some guys having a glass of ouzo, or probably wine would be more likely down in the Agora, about who's the strongest person they ever saw, who was the fastest, who could throw a spear the furthest. Common barroom argument. But if you argue across lots of cities and people and dialects over a long period of time, what emerges there? Every 4 years they get together and figure out who's the strongest, the fastest. They have an Olympics that goes on for centuries. Let's suppose you want to argue about who's going to fix the pothole in front of my house. Somebody else says, yeah, but I got more in my section of town. Who decides? Who decides how much to pay, how much tax should be collected? You argue about that kind of stuff, and if it doesn't break down into a fight or somebody coming in and forcing everybody to stand up and salute, you have the possibility of a new way of decision-making for government. This is where democracy emerges. It's democracy with an asterisk in the bottom of the page you look and it says, no women allowed. We got a lot of slaves, and not everybody that's a free male, but still, compared to other cultures, that's a remarkably different way to make decisions about and for your government. And there's one other thing that happens there that's even more important. If you start arguing and you sustain that argument, eventually you're going to get to a point where you have to have some agreement about what a proper argument is. It's not just cable TV. Okay? It's not a town hall meeting about Obamacare where you just shout different things. There's got to be some understanding of the proper way to argue. And as in so many things, I find guidance on insights into things sociological, philosophical, political in Monty Python. So it's been a few years, but I think this is the scene, and maybe some of you remember a little better than I do. As I recall, Michael Palin goes into a government building where you can pay to have an argument. And he walks down the hall, there's a door, it's open, and it says, arguments here, £5. And he looks in, and there's John Cleese sitting at a desk. And he says, excuse me, is this where I come for an argument? And John Cleese says, no, it's not. Michael Palin says, oh, sorry. He starts to walk away. He says, wait a minute, the door says, arguments here, £5. And John Cleese says, no, it doesn't. Oh, I get it. And he goes in, sits down, gives him $5, and nothing happens. He said, aren't we going to have an argument? I just gave you £5. John Cleese says, no, you didn't. I did too. I saw you. You put it in. No, I didn't. And then again, it's one of these things. Oh, we're having an argument. John Cleese says, no, we're not. At some point, the exasperation comes out, and Michael Palin says, wait a minute. I paid for an argument, a proper argument. This is not a proper argument. I want to have a thesis and an antithesis and counterproof and deduction and induction. You're just negating everything I say. That's not a proper argument. And of course, that is an insight that the Greeks had, and it's amongst the ancient Greeks where this happens, and you don't see that in other cultures. Maybe later, in another time, condition. You've probably heard there is a mythology in some culture, some place, where the world is held up in space on the back of a giant tortoise or turtle, right? I don't think anybody ever believed that. I think this thing appeared as an example of an improper argument. This is the Earth held back up on the back of several turtles. Surrounding it is the snake eating its tail. It's called Ouroboros. What it means to indicate that it stops what is otherwise an infinite regression. The famous story that's told about this is from about 100 years ago, is that there was a leading British intellectual, it's a British story, talking about cosmology and celestial mechanics, and at the end of the talk, a little old lady, and it's always little old ladies. 100 years ago, you could say that. Unfair here because us little old men can't keep up with the little old ladies here. But it's probably, Bertrand Russell is the typical example. And it's an urban legend, it's 100 years old, but she comes up and says, the Earth is held up in space on the back of the turtle. I've read that. And he looks down, condescending, and says, but what's holding up the turtle? And my image is her with her furled umbrella, reaching up and tapping him on the chest. Young man, don't get smart with me. It's turtles all the way down. And that's where that comes from. You need a Monty Python falsetto voice to make that work really well. But if you have rhetoric, language that is understood to be best used in arguing, you have at least, no guarantee, at least the possibility of new things emerging. And that's why I think this was the time and place where some very new things in the history of astronomy and cosmology did emerge. I want to, over the course of this year-long exploration, there will be some times where I'll point out similar situations that allowed the community, the culture, to argue without those two falling off into one of the other side of chaos or utter crystalline stability. And by the way, when I talked about the Chinese last time, do you remember I said there was one period in their history when they were very much into natural philosophy and cosmology? And whether you recall this, it was the period slightly after the period we're talking about here, called the period of the Warring States. It was ended with the unification of China, beginning of the Qin Empire. Excuse me, don't see any more of that afterwards. The Mayans, another great example. Think about if you know a bit about the Mayans, it was a bunch of semi-independent city-states spread throughout the Middle American tropics, forming alliances at times, going to war at other times. No wonder that it was among the Mayans that the most sophisticated, only real writing system developed, very sophisticated mathematical system, the best record keeping in astronomy. It wasn't the great empires of the Aztecs or the Incas that did anything near that. There'll be some other examples, and I'll try and point them out as we go along. So let's start the story in Ionia, at the city of Miletus, the largest, wealthiest, and there are three names that often are thrown out at the beginning as the first of these nature philosophers. I want to point out one thing, though, to get started, get a feeling of the ethos of the time. The peninsula here, the city's built on, it's got a lot of hills. You can see the topography here. Look at the city streets. Hills be damned. This is a rational city plan. They're building at right angles regardless, because that's the best way to do it if you're going to have a rational plan for your city. So the first person on this list is Thales. Often starts off history of science books as the first scientist, mostly because Aristotle called him that. Now remember, we only know fragments of things, and particularly from people who had their own point of view later, and especially Aristotle, because Aristotle read all these people. He told us what they said, he told us why they were wrong, and then he told us what is right, which is his philosophy. But he's making comparative studies. Famously, these guys are going to argue about what the arche is, Greek for the original primordial stuff, the stuff from which the universe is going to be made. Thales says it's water, and I'm not going to pursue that. Some interesting aspects of that. I'm going to stay more focused on the astronomy side. But Herodotus said that Thales predicted a solar eclipse. If so, it was because he was reading the Babylonian records. They would have had the information. It would have been possible to make a prediction like that. But there are two stories, urban legends going back a couple millennia, about Thales. from two very different points of view, written years later. One is that he was walking around thinking cosmological thoughts, looking up at the stars, and fell in a well. Okay, that's clearly not an auspicious way to get astronomy going. And it's clearly the story told by somebody who is putting down this whole business of philosophizing about nature. But there's another story told about Thales, that he was so good at understanding the natural world that he predicted a bumper crop for the next year in olives. And so he bought up all the olive presses that year, so that the next year he cornered the market and made a fortune. In other words, he could put to practical use his theoretical knowledge. Anaximenes thinks the arche is air, but the person I want to spend more time with is Anaximander or Anaximander. He's going to argue against those other two guys. He's going to say water doesn't do any good as a primordial substance because you can't account for all the characteristics in the world, the opposites. Water can explain wetness, but it can't explain dryness. And he goes on about that. And he says the primordial stuff was, the Greek word is apeiron, the boundless, the indefinite. I don't know how far this gets us along, and so I'm going to leave that for now. Because he did give to this story of the development of astronomy something really important, really subtle. He introduced into the Greek world a stick in the ground. Now they called it a gnomon, and it was the thing by which you could tell the time of day, but not that only. It's not just a sundial. A sundial would normally point to the celestial pole, be maybe a little more readable for telling time of day. By the way, the translation is the thing that indicates, or the one who discerns, that which reveals, because not only will it tell you the time of day, it will also tell you the time of year. The shortest shadow of the day, as you know, would point north. So the gnomon not only does it tell you at noon, it will tell you the directions, the cardinal directions of the universe. And then if you watch those shadows throughout the year, you get a change in length between the two solstices. But it's not as straightforward as it might seem. In fact, if you pay careful attention to this, Anaximander, or Anaximander, was the first one to notice, unlike the Babylonians, that the equinoxes did not occur halfway between the solstices, that there was a difference in the lengths of the seasons. You've probably seen this big blow-up view. It's going to be a while before there's a model that can explain this, but at least the observation is made that there's some other motion that needs to be accounted for, the inequality of the seasons. It's his cosmology, though, that's going to have a big impact on this story from now on. He's sometimes called the father of cosmology. Here's his suggestion on the way things are. That we have the Earth as a sort of a disk with land in the middle, surrounded by oceans, surrounded by air, surrounded by fire. There's those four elements that we're going to hear more and more about. The stars, the sun and the moon, are places where there are holes in the atmosphere where the fire outside of it shows through. Now, he's suggesting, unlike what follows, that the Earth is a disk, which seems kind of strange. He also says that its height is 1/3 of its diameter, and I was always puzzled by that. But I think it has something to do with the fact that in Athens, or in that latitude, he's across from Athens, which is the same latitude as the observatory here, just about. The azimuth between the two solstices is 62 degrees, which is 1/3 of the distance from up above to down below, 180. I think it's got something to do with that. He's noticing that relationship. In any case, he is going to argue that what creates the cosmos and cosmos means finding order in the chaos, is the vortex. A vortex spins around through the chaos at the beginning, and like eddies that he would have seen and others would have seen in rivers or in the ocean where there are strong currents, or in dust devils and whirlwinds, heavy things tend to congregate in the center and lighter things are thrown further and further out. And his idea is a vortex of the universe would then separate by density these four major elements. Aristophanes, the playwright that wrote a lot of comedies, put this down as they have dethroned Zeus and vortex is keen. That's an expression, though, at the time is we're not worried about explaining things by the work of the gods. This is physics, or at least natural philosophy. Here's another interesting argument he makes. There doesn't need to be a turtle underneath the earth. There doesn't need to be anything under the earth. Nothing is supporting the earth in space. There is space under it. He does argue that the stars, the heavens go around under the earth. But you needn't worry about what's supporting it. And his argument is extremely subtle. It seems at first it's no argument at all. He says it's there because of indifference. Give me a rational reason that it should be somewhere else. There is none. So it's comfortably there. It's rationally there. Now, some people have seen this as a major beginning, an expression that begins cosmology, to say something like that. You couldn't get away with a statement like that in a lot of other town hall meetings, I think. Now we're going to look at a group that's really weird, but it's necessary to talk about the Pythagoreans. Pythagoras, if he existed, probably did. We don't know anything. He didn't write anything, and what we know is mostly legendary, but his movement continued for quite a while after him, many generations. Supposedly he traveled around through Egypt and Babylonia, and this is a common theme amongst these people. They travel to these other cultures. They gather what those cultures knew, and they sift through it and throw away the stuff that doesn't make sense and improve upon the rest. They're continually comparing themselves to the Egyptians and the Babylonians, even the Indians at times. But what he founds is a cult. It's really a monastery. It's a place where people live and work and study together. And it's all based on understanding the world via mathematics. The arche, the principal, primordial stuff of the universe, is number. Numbers are real. Numbers exist. And you can make a world and a universe out of them. By the way, those who lived in this group were called mathematikoi, math geeks. But since it was also a religious movement, other people were interested, but they weren't really into the math stuff. So you could come and listen to the lectures, in which case you were called mathematikoi. You get the acoustics here. It's where we get the idea of auditors today. That was the first of the allowing auditors to come. You're not going to hear the real secret stuff. That's for people who are living in the cult. It's the world's first monastery, some think. Now here's the famous theorem that Pythagoras did not discover. The Egyptians, Babylonians knew about this, but the Pythagoreans proved it. This was something that you'd give them credit for. What they are going to notice is this is one of many examples where there are a whole number of ratios between things. And when you have ratios like that popping up everywhere, you can think rational about the world. This is the rational approach. That's where it comes from, this idea of finding those ratios. And by the way, as an example, the way I learned the Pythagorean theorem, most people probably heard it too, is the square of the hypotenuse is equal to the square of the other two sides. But the Pythagoreans would have said the square on the hypotenuse is equal to, because this is a square, because let's say the 3, 4, 5 relationship, you'd have 5 stones here, the number 5, and you'd have 5 rows of 5 stones. You could see that that made a square number. And geometry is very important to understanding their thinking of numbers. And here's the secret of it all. This is the inside information that we wouldn't have been allowed to know as auditors at one of his lectures. The magic is the combination of the numbers 1, 2, 3, and 4. Together they make 10. And I'm going to just quickly go over the musical part because mostly that's what they think Pythagoras started with. The first thing you notice, if you pluck a note on a string, the number 1, the 1 pluck, but if you take a string that's half as long or twice as long, that relationship gives you a sound that's very pleasant. It's an octave. If you then strike notes on strings that are in relationship of 2/3, 2 to 3, you get a fifth. That sounds good. If it's slightly off, it sounds bad. If you strike chords on a lyre strings that are in the ratio of 3 to 4, you get a fourth. I don't know why this isn't a seventh. I'm sure Steve knows why it's not a seventh. Why this is a fifth and that's it. Anyhow, maybe we can go into that later. But here's where this is going to get into physics now. The number 1 specifies a point in space. The number 2, the second point, then defines the first dimension. You can have a line. Another point, third point not on that line, defines a triangle, a plane, the second dimension, and the third point not on that plane now engulfs three-dimensional space. This is also important because each side has 4, and what are 4 things important? The elements: earth, water, air, and fire. No matter how you look at it from those 4 sides, there's one in the middle, in the center of it all, which for the Pythagoreans was soul, because they believed in that soul is something that was continued existence beyond the death of the body. It became real popular in the Renaissance. A lot of religious overtones here. So this thing pops up throughout history, including the history of astronomy, and also in mysticism, Kabbalism, tarot, even Christian mystic. Of course, it reaches its highest expression in bowling, but it's called the Tetractys. And this was a secret. This is what they swore by. They would take oaths on the Tetractys. Here's another important consequential thing they did about cosmology, thinking about it. The Earth is a sphere. It's not a cylinder, it's a sphere. And all the planets are moving in spheres, including the sun. The Earth is moving in space. It's not the center of everything, but it's not the sun either. It's a great universal fire called the hearth of the universe. Now this is from a couple generations after Pythagoras. This is the way the monastery sort of developed its cosmology. The spheres are geometric and rational because it's the smallest surface area possible to enclose the maximum three-dimensional space. And they're going to move at different speeds, which we know the planets move at different speeds, but they're going to argue those speeds are harmonic. Not a real bad idea either. And since they're all moving at whole number, rational relationships, harmonic relationships, they create something you probably heard of, the celestial music of the spheres. That's where the idea comes from. Now, the question is, if the Earth's moving through space around this fire, why don't we see it? How many spheres are there here? We got 1 for each planet. So how many planets? You got 5 naked eye things, sun and moon, that's 7. And then you have the Earth, 8. And then you have the fixed stars, which are rotating, 9. What does it have to be rational, to be perfect? What does it have to be? Aristotle said they put this thing in there because the number 10 was perfect. So that's Aristotle saying this is what happens when numerology takes over. You lose sight of what you're trying to understand. Okay, we switch to, by the way, the Pythagoreans are important from another point of view. When we eventually get to Copernicus, in his famous De Revolutionibus, he refers to that model and Philolaus, the guy that's given credit for that. And everybody pretty much up to the time, including the time of Galileo, is going to refer to Copernicus's idea as the Pythagorean theorem, or theory, excuse me. So that idea of the Pythagoreans is going to hang on quite a while. So here's the first of the Ionians to come to Athens in the golden age of Athens, Anaxagoras. His argument is the arche, the primordial stuff, is not one thing, it's two. It's matter, and also permeating all the matter is nous, a Greek word for intelligence. There is intelligence permeating everything, including us. It doesn't always get well seated in us, but it's everywhere, which allows for the intelligent design of the universe. It's nous that creates the vortex that Anaximander talked about. The problem that Anaxagoras explains, though, is that that sorting work of the vortex is not complete. It's not done. There's still some rocky things up in the heavens. One thing's obvious. You can see rocks going through the atmosphere burning up. Some of them hit the ground. That's left over a not completely sorted celestial spheres. But he's going to also argue that the sun and the moon are just big rocks in the sky. No mythologies, no gods connected to this. The sun is a hot, fiery rock, and really big. He says it's as big as the Peloponnese, which is that lower part of Greece. It's that big. But he's also going to say the moon is cold, doesn't have its own light, it's lit by the sun. And that's the reason that you see the phases. It's also the reason that there can be an eclipse of the moon because it gets into the shadow of the earth. Or an eclipse, or an occultation, I guess would be better, of the sun when it gets in front of the sun. He's explaining in physical terms something that probably the most powerful celestial event anybody will ever experience. Scary stuff if you don't understand what it is. And he's coming up with a very simple, straightforward explanation. It's one that doesn't please everybody, and in fact he's charged with impiety and he has to leave town. Gets out of town just ahead of the mob. Not everybody is into this philosophical stuff, I must say. There's still people that make offerings to the gods, etc. But the big name philosophers don't pay attention to that unless a mob forms. And now somebody that I'm sure you've heard of, or at least his theory, Democritus, is the one that's going to argue that it's all atomic. He's going to have this atomic theory where it's going to argue something strange. Everything we see is a combination of these tiny atoms that can't be cut anymore. That's what the word atomic means. And various combinations can explain all the diversity in the world. So the only thing that exists, the only thing that is real, are atoms and one other thing. He's going to say nothing is real and nothing exists. He would have probably said it a little differently. He would have said nothing is real and nothing exists. That's a strange idea. It's the first time anybody's argued like that. The void exists. It's all atoms and the void. You got an infinite amount of time, an infinite number of atoms, an infinite number of possibilities, what might come of that. And one of the things that will come of that, maybe already has, maybe will sometime in the future, is other worlds, extraterrestrials. The idea of other people on other worlds appears at this time. And it will pop up again and again throughout the coming 2.5 millennia in this story. All this, of course, sounds very modern. the atomic theory is not very much like our atomic theory today, because there's nothing atomic about the theory today. It's all pieces parts today, but the concept is important to deal with. Oh, that's his famous statement. We're going to come back to that and maybe understand that in a little different perspective. So, all of this philosophizing is going to come to a sudden screeching halt because of this man. Now, at this point, Socrates is reading, listening to all the philosophy around him, and here's what he observes. What has been put out there has been argued about cosmology and the nature of the world. There are people who are arguing it can all be explained as development from one arche, one primordial stuff. No, it was 4 different elements. No, it was an infinite number of atoms moving about in nothing. Some even argued that no, it was numbers themselves that accounted for everything. There are people who are going to argue it's by design. No, others it's all by chance. Some said it's permeated by a force field. There were others who argued there were multiple force fields acting in contrary manners. You could understand it by experience. No, you had to understand it only by reason. It all began with a Big Bang. No, it's eternal. It's just a steady state. If any of you know a bit about the history of life on Earth in biology, there is a famous period in the fossil record called the Cambrian explosion. It's about 500, a little more than 500 million years ago, 570 million. So where in the fossil record, every basic phyla is represented. Every way that it's possible to structure a body plan for an animal is there. There's been a lot of change since then, but mostly it's been refinement. You add extra limbs or body parts here and there, antennas hanging off, whatever. But the basic ideas are there. I see this point at the time of Socrates, prior to it, that axial age in ancient Greece, as the Cambrian explosion of philosophy, of natural philosophy. All of these ideas are still with us. They're still being argued about, and they're going to pop up again and again in this story. It's interesting, nothing wins out and goes away. But Socrates is going to argue that enough of this. From his point of view, the world is in existence because of a divine craftsman, a god, using intelligent design that made the world as perfect as it can be. This is impious on the part of all of these philosophers to think that they can understand the mind of this intelligent designer. What a waste of time. If you want to do philosophy, you should do the philosophy that has to do with how we interact with one another. Ethics is the proper philosophy. Now, this brings up everything short because whereas he didn't write anything and he drank the hemlock, he has a student who's going to be one of the most important intellectual figures in the Western world, at least, and beyond, and that's Plato. Plato writes about the death of Socrates, and he writes lots of other things. But after Socrates died, he goes and travels for several years and ends up in Sicily and studies with the Pythagoreans. He's going to learn the mathematical approach to cosmology. He comes back to Athens and he starts his own school with a famous name that we've used again and again ever since, the Academy. And it's going to last for about 700 years. Big impact on the world. In the picture, and this is, everybody's seen parts of this picture, Raphael's picture of all the Greek philosophers, plus some others, and it covers more than 1,000 years. It's not just Athens in a certain century. But in the center of it all is Plato pointing up. The idea is the truth of this world is not in this world that we can see and hear and touch. It's out of this world. It can be accessed only by thinking great thoughts and clicking your heels together 3 times. And it's based on mathematics, the way he learned it from the Pythagorean. He's holding a book, by the way. A lot of people miss this in the picture. Whoops, why didn't... okay. The book is one I'll get to in a bit. I thought I had something there to explain it. Anyhow, so he's going to come back with this Pythagorean approach to understanding nature, set up a school, invite people in, and give them a challenge. And this is the book he's holding under his arm. It's called the Timaeus. It's the only book of cosmology that he writes. Unfortunately, it's the only one that gets translated into Latin and ends up being read by people up through the Middle Ages. The Renaissance has to wait for a rediscovery through the Greeks to get his other stuff. This is a story about how the world was formed, the universe was formed, told by a Sicilian philosopher named Timaeus. And it's going to sound very much like a Pythagorean talking. The god that's going to do the designing, it's a demiurgos in Greek, because it's not a biblical god. This god is an intelligent designer, but he's got some things to work with. Besides God, there's matter. It's in chaotic form. And he has one other thing. He's got mathematics. He's got Platonic forms and Platonic ideals. And he's going to impose the mathematics on the chaos of matter, and we get a world that we see around us now. He's going to create the four elements. So there's the Greek word for this god, a demiurgos, a demiurge. He's going to create the four elements mathematically. Okay, there they are. How does he do it? Well, remember the tetractys. If you specify a point in space, okay, there's a place. Another point connected between them creates the first dimension of a line. The third point not on that line creates the plane of a triangle. And a fourth point encloses three-dimensional space in the simplest, most economical, rational way it's possible to begin a three-dimensional world. It's all done with triangles put together, and there are only these four and one more Platonic solids, they're called, that look exactly the same from every side, that can be made by putting triangles together like that. A cube, by the way, you know, you can make two right-angle triangles. So this is a perfect rational way to describe the enclosure of space in four of these five possibilities, and assigning to each of them one of those four elements that most people at this time are thinking, oh, it's probably right, that's probably what the elemental stuff was. Now, the chaotic matter exists outside of God, outside of the math, and it resists. The God does a pretty good job, but it's not perfect. The world we see as a result of this effort is not perfect. Things grow and wither and die. Mountains lose their original shape and erode. The world that we can experience through our senses is not perfect. It's only the world you can think about rationally that's perfect. And we're almost there if we can access that perfection rationally. Now, necessarily, this cosmos had to begin with a Big Bang. You can't have almost a triangle. You can't have a triangle that's nearly three sides. Or you can't have something that's almost true, that's 87% true. It's either true or false. So it's this rationality that imposes the concept of a Big Bang. Later, Christians and other monotheists will latch onto this and think, wow, that fits in with what we were talking about, a God that created things out of himself, out of nothing, but all at once. Now there's a fifth element that's suggested too, because there's another possible perfect solid, and that's the 12-sided dodecahedron, and that one is going to be assigned maybe to the heavens. More about that in a minute. Now, this is getting deep into philosophy, but we'll escape pretty quickly. But I'm doing this only because I think it's necessary to understand what's going to follow century after century. There are two different concepts that are being argued about here by all these philosophers, including especially Plato, and Plato's going to put it all together. The things that exist either exist absolutely necessarily a state of being, or that they're in a state of continual change, which they call becoming. For the Greeks, the word for things that exist necessarily is episteme. You may recognize that connected to a branch of philosophy called epistemology. It's how we know stuff. For the Greeks, you can only know stuff that doesn't change. But the Greek word for things that change, that knowledge is doxa. If you want the correct understanding of the popular notion for now, what's popular now, you can ask the priest or policeman for the orthodoxy. That's where you get that. The reason I have this is because in a lecture or two, 3, the Romans are going to take over all this, and we're going to hear this in Latin. And in Latin, look what the word is for episteme. It's scientia. It's going to mean science to a lot of people. Whereas this kind of knowledge is, does that ring a bell? Now we can understand Democritus a little better. And also there's another person who made use of this. It's somebody with a classical education, a Rhodes Scholar at Oxford a few years ago. And that's what he was talking about. Forgive the guy, that's what he meant. Our languages, some languages still have that distinction. Spanish does, soy and estoy. There's a difference between things that are necessarily true and things that are true now. There are no penguins in this room, but that's not necessarily true. You know, we could probably work out a way for that to be false in a month or two. But the things that are necessarily true, people thought necessarily was the basis for doing science. So Plato sets up his academy, hangs a sign under the entranceway, let none but mathematicians enter here. Sounds like the Pythagoreans again. If you're going to come and work and live with us, you got to know math, which meant geometry to these people. And he's going to challenge the people in his school, famously, to account for the irregularities in the heavens using certain knowledge of mathematics, using geometry especially, using the spheres, uniform circular motion. And this is the way it's expressed, often translated, by the assumption of what uniform and orderly motions can the apparent motions of the planets be accounted for. By the way, the word planet, of course, you know, is a Greek word. It means wander. It means it's not perfect. They're going crazy at times. Is there a way to understand that by reasoning about it mathematically? And so this is the challenge. Now this is an image thought to be from Plato's Academy. And one of the things that Plato famously said is if you want to understand astronomy, you have to turn your back to the stars. As an amateur astronomer, and all of us here, and maybe Carlos is about to leave that status, but my reaction to that is sort of, eek! And what do you mean? That's the whole joy of this business of astronomy. But the challenge is going to be picked up famously by one of the fellows of the Academy, Eudoxus. And we think that's Eudoxus because he's pointing down here to a model he came up with using the geometry of spheres like the Pythagoreans did, but he's going to do it a little more sophisticated way. There are going to be a bunch of spheres, not just 10. There's not going to be that anti-Earth that blocks the view of the central hearth of the universe. There will be an outer sphere rotating once a day carrying the outer stars, but then there'll be a sphere carrying the planets doing that too, but other spheres for the planets going in the other direction at the speed at which they reverse against the background of the stars, and the sun will have its own sphere going backwards once a year. It will also have a sphere that's tilted at an angle of 23.5 degrees, so you can get the ecliptic accounted for. And altogether, this model is going to take 27 nested spheres. Now, this is a mathematical, conceptual, theoretical model that sort of satisfies those that want to think great thoughts, close their eyes, and turn their back to the stars, because it doesn't explain a bunch of stuff. And so some others are going to pick up on those problems and try and refine it. Another guy there, Heraclides, suggests, oh, I thought of one other way to add a sphere that will be real convenient. Why don't we just have the Earth spin on its axis every day? Wow, great idea, but it's a great theoretical model idea that's sort of folded in with the rest, and nobody really picks up on it. Those that are upset by this model don't pay much attention to that. This model is qualitative, not quantitative. But another student, a fellow at the academy for a while named Calipers, and here he is having a bad hair day, sees some problems. The inequality of the seasons is something that he notices. He does some careful observations, and that model won't explain this. So he adds some more spheres, and he puts them at different angles, and it's possible to nest a sphere that's rotating like this with one like this, and you can get complex motion like this that describes what the Greeks called a hippopede, the thing you put on horses to keep them from running away, sort of a figure eight, which begins to look something like an analemma. But he thought they needed another 7 spheres, so the model now is 34. He leaves the academy, and then when Aristotle comes back and starts his school after a bunch of years, he starts working with Aristotle, and we now have to switch the story. There's the book of Timaeus being held by Plato, but his star pupil is Aristotle, and this is remarkable. What we're doing is going from Socrates' big pupil is Plato, his big pupil is Aristotle, and a pupil of Aristotle is going to end tonight's story with a big impact too. But Aristotle's carrying a book too. It's a different one. By the way, notice Plato's pointing up, Aristotle's doing this. I think if there was video, he was probably going, For him, the truth of this world wasn't out of this world, it was very much in this world. It's accessible by the senses, but also by reasoning, but not mathematical reasoning. What he didn't like about Plato's world is Plato didn't explain how these laws of math actually interacted with matter. Where do they touch? How do they interact? Aristotle said the secret to understanding this rationally is not through math, but through causes. What causes things to happen? And you need a good logical way to understand those causes and make arguments. We didn't have good logic at the time, so he takes care of that, and he writes the first book on logic. It's called the Organon, the rules of reasoning, and it will be the sort of the scientific method for quite a while. Now here he is in middle age, thinking some more on this. Now I said that he has gone around and read, this guy reads everything. He had the first big library in the world. Famously collected everything he could get his hands on, but he read all those pre-Socratic philosophers. They were called PreSocratics by by Aristotle. He pointed out that this work ended with Socrates, and he analyzed their writings, improved upon them, but only about 20% of what Aristotle wrote has survived. So we know a lot of this stuff from other people that wrote about what Aristotle wrote or commented on what Aristotle wrote. So it's part of the story how we put fragments together. In any case, the one pre-Socratic philosophical cosmological system that he hated was the atomic theory. This made no sense to him. He famously said, nature abhors a vacuum, a void. That doesn't make rational sense to say that nothing exists. You can't think about nothing. So he's going to develop a physics of this world where things are always touching other things as they move. Motion involves contact. And in this world, things start off in a straight line, but they get continually bent and bumped by other things, other causes. He was bothered by that model of Eudoxus being just mathematical, but he thought that there was something of value there that he wanted to save, and so he's going to say, it's not theoretical, it's real, it exists, and those spheres are made of something. They're made of that fifth element, and that fifth element is ether, and it's all ethereal up there. And to bring this off, he realized, though, that there were some problems. It's going to take 55 spheres to do this. He noticed that there would be an argument that there'd be one outside sphere operating once every 24 hours. That moves everything else inside. And Eudoxus had one of those for each of the planets. You've got to have another sphere going in the opposite direction at the same speed to unwind the system. So that's how he came up with 55 spheres. Elegant, it's not. But it's reasonable from his point of view. And here's the system that he came up with. This is at least the medieval view of Aristotle's system. They watered it down, didn't need all those 55 spheres, couldn't understand a lot of them, but this is what we end up with. We've got the four elements in the center, the earth made of mostly the element of earth, but not completely, everything's mixed. Around that are the oceans and water, mostly of that element, but not completely, surrounded by atmosphere, surrounded by fire, and then from the moon on up, it's all ether. And it's all moving in uniform circular motion. So you got two different physics. You have the physics of this world that we can experience and see, where everything is changing and moving more or less in straight lines and less bumped into a different direction. And by the way, this realm of fire is explained. There are fiery things that aren't in the heavens and aren't made of ether. For instance, meteors. And that's why when he wrote a book about it, still today, if you're going to study the atmosphere, it's called Meteorology, because Aristotle wrote the book on it. But from here on, you have a different physics. There's only one element, it never changes, and everything moves exactly the same forever, eternally. There was no Big Bang beginning, and there is no end in sight. Here's the problems. You can tell, at least I feel, that Aristotle wasn't much interested in astronomy. He was interested in explaining everything, and he made a valiant effort at that. But he famously said, you can't really touch the heavens. You can barely see what's going on. There's no way to interact with it, get a good experience of the heavens. It's like getting a glimpse of a loved one that appears shortly and disappears from view. You feel this pang. You would like to have had a more intimate relationship, somebody that you loved, but you couldn't interact with. That's how he felt about astronomy. So here's his system. It's pretty funky, but here are the two major problems for the rest of the talks that I'll be giving. Problem number one, Aristotle isn't much of an astronomer. Problem number two, he's going to be the world's foremost authority on this subject for the next 2,000 years. Okay? And here's why. Just to complete it, there are the speeds at which the various rings rotate. But the reason it's going to have a big impact, one of the reasons, a primary reason, one of his students is a little bag of testosterone that's going to take off after getting a good Aristotelian education and decide that he wants to conquer and unify the world. That's the goal. Conquer the world, uplift civilization with Greek understanding. Oh, and there was number three was kick Persian butt. That was a big one too. And he was real good at all of those. So the next time we get together, the story's going to change very different. Won't be near as much theory. We're going to now switch to a time where the world becomes Greekish. It's called the Hellenistic times. A lot of different cultures are going to be integrated, many of them literate in Greek, and blending other approaches, particularly Persian, some Indian, and a lot of Babylonian into the system. Less interested in cosmology and more interested in specific little problems to solve. Whereas the ancient Greeks could prove that the square root of 2 was irrational. The Hellenistic proto-scientists are going to not much care about that. They're just going to calculate the square root of 2 to 17 digits and make use of it. And it's going to be a time where they won't be arguing about how the sun and the moon and the earth came to be. They're going to set about figuring out how big is the sun? How big is the moon? How far away is the sun? How far away is the moon? And they're going to make a real good argument for the earth spinning on its axis and rotating around the sun. All of this is going to happen next month. So that's where, and this is 1,700 years before Copernicus makes the argument.